Okay, so for this question, we have question 2, the number patterns, 5, 11, consider the sequence 5, 11, 19, and 6 plus 8 plus 10. So we can see we're jumping, our first difference, 6, 8, 10, is jumping with 2, so the next one, that's why we recognize that this is a quadratic sequence. If we look at the student's attempt, we see he sees that he starts with 5, 11, 12, continuing, and then his second difference is constant 2, and the first question is to find the next two terms, and the next two terms is then plus 12 and plus 14, so they give me 41 and 55. So well done on that student's answer, it's good. The next part is determine the formula of the nth term of the sequence. Very simple. A plus b plus c is equal to 5, 3a plus b is equal to 6, and 2a is equal to 2, and then solving this with the three equations, and then getting that final answer. That's perfect final answer. Well done. If you didn't know how to do that, pause the video and watch, but actually if you didn't know how to do that, then we've got serious problems. Okay, what is the value of the first term of the sequence that is greater than 271? So the question is, what is the value of the first term that is greater than 271? So for example, in his answer, he finds out what is the term that is equal to 271. Which term is 271? It's term 15. The question is, which term is, what is the first term that's greater than 271? And the first term. So in other words, in the end, this is what he should have gotten. He should have kept his greater than 271, and then he should have just drawn here, there should have been greater than 0, and so his answer should be terms less than negative 18 and greater than 15. The first term greater than 15 is therefore term 16, and you had to then go and calculate, substituting 16 in here, what is the first term that's greater than that? And that would be 16 squared plus 3 times 16 plus 1. Okay, and that gives us an answer of 16 squared plus 48 plus 1. It's 305. Okay, 305. That's the value of the first term greater than 271. Okay, and yeah. Okay, next question, question 3. Given this sequence x832, determine the value of x if the sequence is arithmetic, and determine it if it is geometric. So it's three marks if it's arithmetic or geometric, and the student used the arithmetic property, which means we take term 2 minus term 1 is equal to term 3 minus term 2. In other words, constant difference, and he gets 20. So let's just see. If I add 12, I get 20. If I add 12, I get 32. So I get a constant difference. Then for the geometric property, he does the following, and this is correct, but he only gets 2 marks because my pen. Okay, because, and it's worth 3 marks. So he uses that one, he gets that answer, but it's x squared is equal to 256. So it should be plus minus. Okay, in other words, the constant ratio could have been times 2, and so I'm just multiplying by 2 every time, x times 2 is 16 times 2 is 32, but it could have also been negative 2. 8 times negative 2 is negative 16, and negative 16 times negative 2 is positive 32. So x could have been either one, so it only gets 2 marks. Solve for n. Okay, so basically the question is how many terms are there in this sequence? And let's just see what he did. He started off by writing out, in other words, just substituting I with 1, and you get 3 to the power of negative 4. I with 2, 3 to the power of negative 3. And he substituted that, you got a sequence. It's exactly what you have to do. When you see a sum, just use the first 3 terms of every, and get the first 3 terms and figure out what type of sequence it is. He sees this is an arithmetic series. Should have just done the plus. Okay, arithmetic series, excellent. Geometric series, and each time I'm multiplying with 3. Notice that I'm 1 over 81 times 3 is 1 over 27 times 3 is 1 over 9. My numbers are getting bigger. The next one will be plus 1. The next one will be plus 3. Okay, and so the question now is, when is this sum equal to the sum given in the question? 364 over 81. And so that's what he does here. 364 over 81. First term is 1 over 81. And now he simply goes and solves the 3 to the power of n. He's trying to get 3 to the power of n by itself. And notice what he does. In the bottom, he gets 3 minus 1 is 2. So he multiplies the 364 with 2 to get 728. Now we divide both sides, or on both sides we have a divide by 81, so they can just cancel. So I have that 7 to 8 is equal to 3 to the power n minus 1, so the minus 1 makes it 7 to 9, and 3 to the power of 6 is equal to 729. Excellent work. Well done, student. Good question, good answer. Prove this theorem, or this that if I sum the first if the first term is a and the constant difference is d, and I sum n terms, then I can write it as that. You have to prove that. Okay, the student skipped the proof. Hopefully it's because he knows the proof. Sincerely hope it's because he knows the proof. But yeah, I'm not going to show you the proof. The proof is in the course, and you have to know this proof and the proofs that if I sum the terms of a geometric sequence. Okay, so those 2 proofs you have to know, and come on, that's 4 marks. I want to see you guys do it. Okay, here, why does the sum to infinity exist for this sequence? Very good answer. He says it will exist if r is bigger than negative 1 and smaller than 1, and he shows that the constant ratio is 1 over 4, which is in that category. Okay, and then determine the sum to infinity. I mean, it's a super simple answer. You just substitute into the sum to infinity formula. First term is 64, and the constant ratio is -1/4. So very good, and that is the number patterns for this paper.